Hello, welcome back. In this lesson, we're going to develop the UART write function, and this function will be used to transmit data. So I'll come over here and say void over here, and I'll say UART. Let's see the name. Okay, UART. So we're not calling this UART2, just UART. Okay, so UART underscore write. Takes no argument. Okay, so what we have to do here is that we would have to make sure the transmit data register is empty before we put the new piece of data to be transmitted. So I'll say over here, make sure the transmit data register is empty. And once that is done, we're going to write data to transmit. I'll say write to transmit data register, or write to transmit data register. Register like this. Okay. So to make sure the transmit data register is empty, we need to check the status register. To make sure the transmit data register is empty, indeed, we need to check the status register. But that sounds confusing. Check one register to see if another register is empty. But what we really need to check is a particular bit in the status register. Okay, so let's go and find that bit. To do that, we go to the reference manual. I'll go up here. I'm looking for the status register. So UART SR. This is it, the status register over here. And bit number 7 here is known as TXE. Let's see what it says. It's the transmit data register empty. It says if this is 1, data is transferred to the shift register. If this is 0, data is not transferred to the shift register. Okay, so we would have to create a symbolic name to hold this, bit number 7. So I'll come over here. I'll say define over here. And the name of the register is SR. And then the name of the bit is TXE. And this is bit number 7, like this. Okay, so what I'm going to do is I'm going to read this bit. To read this bit, we simply perform an AND operation with this, using this bit as one operand and the register that we want to read from as the other operand. So I'll come over here. I'll say UART2 over here, status register, and bit number 7. And I'll say if this returns null, if you perform an AND operation, and bit number 7, if the result is 0, it means one of the operands is 0. And since we know this has bit number 7 set to 1, then in the status register, bit number 7 is 0. So if that's the case, we want to get stuck here. So we have to wait until, bit number 7 is set to 1. So we say if not, or while not, we simply get stuck here. So this blocking code. In interrupt mode, we wouldn't use this, but we don't have an interrupt configuration. However, if it is set to 1, we would skip this line and then come over here. And over here, we would say UART to data register. And actually, our function should take the character we wish to send. So I'll say int ch over here. So UART to data register equals ch and 8-bit. So 0xff over here, like this. Want to transmit 8-bit into this register. Okay, into this. So this is it. So we can use this to transmit a character. But what we want is we want to transmit sentences. So what we're going to do is retarget printf. We're going to be able to use printf with our UART. To do that, what we would have to do is we would have to include stdio.h, and we would have to perform the retargeting. So I'll come over here to the top, and I'll say over here include stdio.h, and over here to retarget, we're going to implement the code at the top over here. You can implement it anywhere, but I often implement it here. So we say int over here, and we know this because there is a template of this function provided inside our st header, inside our st files. One of the files has this anyway. So we say __io _put char, and then we say int ch over here. And then in here, we're going to call our UART function, our UART write function. First of all, I'll get a prototype, put it over here. And because we don't need it outside, I'll just make this a static function. And then come down here and make it static as well. So we're going to call our UART write function in here like this. And then we pass ch, and we return ch. And this piece of code would allow us to use printf. We've basically retargeted printf. So once this is done, I'll do Ctrl S to save, and then expose this function. Double click this, copy this, come to the .h file and paste it in here like this. And then put a semicolon here, and then Ctrl S to save, and then come to main.c file over here, and then I'm going to include our uart.h file. And once that is done, I'm going to call our UART init function, copy this, and then paste this over here. And over here, I can simply, I'll delete this. We don't need this. You can keep it if you want, but we don't need this. And over here, I can simply say printf. And over here, we can say hello from STM32F4 and new line courage return, something like this. Okay, so now this message is going to be sent to our computer. To be able to view this, we need a serial program, a program on our computer that's able to accept, serial data or UART data and then print it for us. So we need a terminal program, or as it's often called, a serial terminal program. So we go to our browser and download one of the popular ones out there. I'm sure if you've taken any of my courses, you probably have this already downloaded. I'll come here and I'll say download Realterm. Realterm is one of the popular ones out there. So we can get it from SourceForge. I'll come over here and then I'll click to download it. And this is it. It's finished downloading. And we can install it by double clicking it. And then we say next. It's a simple wizard. And then next. And then next. And then install. I'll simply say OK over here. You shouldn't get that. And then I'll say finish over here. Okay, so once that is done, I'm going to build my project. Highlight this, click to build. It says we've got 3 errors. Let's find out where the errors are. Void value not ignored. Okay. I forgot to put return over here. We're returning this. Okay, so we've got a return, and this is uint 16 underscore t. I'll copy this, update this function over here. I'm going to include stdint as well. Let's build again. Highlight this, click here to build. Build successfully. I'm going to right click over here. I'll say run as STM32. And I'll say OK over here. It's getting it onto the board. It's downloaded successfully. So I'm going to open real-time, the program we just downloaded. And when you open it, this is what it looks like. What I'm going to do is come to the port tab and select the baud rate. The baud rate we configured our UART to use is 115200. And then the port over here, I'm going to select port number 4. The reason I know it's port number 4 is that I know this is the port of my board. For you to find out, what you want to do is disconnect your board and then open real-time and see the ports over here. And then take a note of them and then close real-time and then connect your board and open real-time and click this drop down again. You would see that a new port appears. That is the one that belongs to your board. So I'll click port number 4, open and then open. And as you can see, hello from STM32F4. The message is being printed. The same message we are sending. Okay. This is the message. Okay. So this is it. Our UART driver is working as expected. So we'll use this to be printing information from various threads or tasks. So that's all there is. I'll see you. Have a nice day. Take good care of yourself.